The purpose of this animation is to illustrate how CTD and CTU counters can be used in pairs. Here we have the CTU up counter and CTD down counter. Both of these counters have three input fields: the counter reference field, the preset value field, and the accumulated value field. These counters can be combined to form an up-down counter by using the same value in the counter reference field. With both counter reference fields set to the same value, the counters will share the same preset and accumulated values. The count up and count down enable bits still operate independently in this configuration. The counterintuitive behavior of the done bit for the CTD down counter allows for the combination of these two counter types. The done bit for both of these counters will respond in the same way with respect to the preset and accumulated values. The done bit for each of these counters will be set whenever the accumulated value is greater than or equal to the preset value. We will use this type of counter pair to control the hoist action for a two-floor elevator application. We'll begin by outlining the I/O mapping for the elevator application. The first floor call button is connected to input rack 1, bit 6. The second floor call button is connected to input rack 1, bit 9. And the rotary shaft encoder is connected to input rack 1, bit 15. In terms of outputs, the first floor call indicator is connected to output rack 2, bit 6. The second floor indicator is connected to output rack 2, bit 9. And the motor hoist controls are connected to output rack 4, bits 0 and 1. We will now move on and examine the hoist control program for the elevator application. The hoist control program consists of two sections. One section for status tracking and another for output control. The first section tracks the location of the elevator car. Two sets of counter pairs are used, one set for each floor location. The first floor location is detected using the done bit of the C51 counter pair. The second floor location is detected using the done bit of the C52 counter pair. NO and NC contacts allow the counter pairs to be triggered by pulses from the rotary shaft encoder, which is connected to input rack 1, bit 15. The two up counters are situated on rung 0, and both down counters are located on rung 1. Pulses from the shaft encoder can only impact on the up counters when a call to the second floor has occurred. Similarly, the CTD portion of both pairs is active only when the first floor call button has been pressed. The output control section also uses these two call button inputs to control the hoist direction. The state of the done bits for both counter pairs are used to stop the hoist when the elevator car reaches the requested floor. We will now examine the program during execution. This will illustrate the way in which the done bits act and how they stop the up or down hoist outputs on rungs 2 and 3. The C52 counter pair's done bit will only be set when the car reaches the second floor, which occurs when the accumulated value is equal to 42. The setting of the done bit breaks continuity on rung 2, and the motor hoist up action will be stopped. The only time that the C51 counter pair's done bit is unset is when the car is actually on the first floor and the accumulated value is 0. This means that an ongoing hoist down action will be stopped by the continuity being interrupted when the bit is unset on rung 3. It is important to gain an understanding of how these counter pairs work by watching the behavior of the done bit and how it interacts with the hoist up and hoist down action of the elevator motor. As can be seen by this demonstration, counter pairs are capable of keeping a running total and are extremely useful in a wide variety of applications.